Hello, good morning, class. Today, we will be discussing what operators are, as it is going to be important in our next lesson, which is going to be discussed next week. For tomorrow, we will be focusing on our robotics class. So, we will have a reprieve from our lessons regarding robotics tomorrow. But today, we will be discussing what operators are. So, again, in our previous lessons, we have already discussed what operators are. They are important in manipulating the data that is contained within our program. So, there are major operators that we are going to use in our project today. So, those are arithmetic operators, assignment operators, logical operators, and comparison or relational operators, which we are going to try to make use today. So, we are going to start early. I would like you to create a new project and name it last name underscore operators. So again, our project for today should be named last name underscore operators. So upon creating our project, I would like you to go directly to your activity main.java, go to the design tab, and make sure that the hello world has an ID. We will be reusing what already has been used yesterday. So I would like you to name the ID of hello world as display text. So name it display text. For a simpler solution, you can reuse the code that we have used yesterday. You can just copy the code that we used for our XML yesterday and paste it here. Now, moving on to our main activity.java, which is the class the Java class in which we are going to program. So, I would like you to add these two lines. Again, this is important in displaying or putting output into our screens. So, text view display, then display equals find view by ID, then tag the ID to the ID that you have used for the text view, which is display text. So R ID display text. So now we will be using uh, each of those operators listed earlier. So again, we have four major operators that I will be typing here so that everything is clarified. There are arithmetic operators. There are assignment operators. There are logical operators. And there are comparison operators. There are also what we call bitwise operators which operate on a bit by bit basis, but we will not use it for this instance. We will be using this for classifications of operators. So for arithmetic operators, we are already familiar with uh, the basic arithmetic operations that we use in our daily lives. There are four. It is addition, excuse me, addition, subtraction, multiplication, division. Now, uh, programmers employed a new type of operator that is not be commonly used in a daily basis, which we call as modulo, which is basically a division operation operator. Division operation remainder. For example, um, for example, 5 modulo 2, then the modulo would be 1, meaning it is the remainder between that division operation. So let's try things out. I would like you to create two double variables. It's up to you what your name is. So for me, I will be using double x. Let's instantiate it to 0 and double y. Again, instantiating it to 0. Now, we are going to uh, create an operation out of this. The best example in which is already shown on the Blackboard module is 7 and 3. So let's assume the first operand would be 7, and the second operand would be 3. Now, we will try to recreate the operations being used in the table. For example, um, x plus y. So let's try displaying the output of between x plus y. So how are we going to do that? So let's type display dot set text. Then again, if we are going to display double, we need to convert it to string first, right? We need to convert it into string data type first because we are dealing with double. We need to convert it to string first. So we are going to summon the string class. So string, then dot string dot value of, then x plus y. Now, let's try running this program if it really shows the output. So executing the program now. So it shows up that 7 plus 3 is equals to 10. Now, we will be testing other operators as well in our mathematical, or rather our arithmetic operators. Let's say, and let's make this a bit more cleaner so that it is visible to you. So let's say our operator will be uh, the subtraction operator. Let's try rerunning the program again. So 7 minus 3 is 4. Um, let's make this a bit cleaner for the eyes. Let's make this appealing, visually appealing. So let's add some text. So let's try uh, the value of uh, let's say we'll be using multiplication now. So the value between x, let's add plus here. So we are going to bind the strings together. We call this concatenation, okay? Here's the terminology for this. We call this type of binding of strings together concatenation. So in this instance, plus is not an addition operator. We call this a concatenation operator, meaning it concatenates or binds the two strings together. In this instance, plus or the addition sign is not an addition operator. We call this concatenation operator. So now we are going to bind the two, or rather, let's pull this away. Let's take this so it won't interrupt with the X and Y process and add it here. So the value between, let's maybe pull string X here. The value between string value of X, then add another, then let's put another one. I know it gets a bit confusing for you to look at. So let's try to divide this one by the plus signs that we have already used. Okay? So the value, so let's say like this. The value between, so this is the first string, then we concatenated it with the value of x. So it shows the value of x. Then I added a white space here. Then let's add another one between maybe and. Let's add the word and here. Uh, the value between string value of y. Then let's add another string uh, s. So let's move this away. Mm, should be here. Okay. So we added string literals here. The value between, then it converts x into a string. So a number should show up here. Then another string literal. Then the value of y being shown as a literal. Then the literal string is. I think it's better to show it to you so it would be understandable. Okay. So let's try rerunning the application. So the value between 7 and 3 is 4. If you have any questions, please type in the chat so everything would be clear. Or you can uh, give me a message later. So maybe make it so that the sentence is a bit more structured. The value between x and y in an, let's say in an, let's add one more, in a, in an, in a, let's say division this time. Division operation. So the value between, let's add a line breaker here. So now, again, this is a line breaker. So it shifts the line below. Oh, I think this is a bit better, right? Maybe position the line breaker in a better one. Let's say let's put it here. So the value between 7 and 3 in a division operator is 4. Again, we haven't modified the division or rather the operator symbol yet. So let's try the division operator this time. So the value between 7 and 3 in a division operator is 2.333. So at this point, you can make sure or make your program decide if it is going to cut the other values. As you know, as you may see here, it is kind of long, right? Now we are going to modulo operator. So we are going to use modulo, which is a percent sign. It is the function key of number 5. So let's see here, modulo. So the value between 7 and 3 in a modulo operation is 1. It means that there is only one remainder when 7 is divided by 3. So that is a modulo operator. Now, we will be going with the assignment operator. The simplest assignment operator is the one using equal symbol. That's why I'd hate you to use the equal sign as literal terminology for equals, because in programming the equal sign means that it is assigned to. So for this instance, if we are going to translate this the word, double variable named x has been assigned a value of 0. For this instance here, line 30, a double variable named x has been assigned a value of 0. So, at the most basic sense, assignment operators are unary operators, meaning um, it can operate with a single operand. For this instance, the operand is x. So it can function even with a single operator or operand rather. So let's try out other operands. Okay, so let's try removing everything here and reset it. So now that we have resetted everything, um, we will be using x in this instance. So x would be, or rather, y would be useless in this instance. So for example, let's display um, what would be a great number? Let's say we will not modify this. X is equals to 7. So let's say uh, x, or rather, let me string that value of so that we can display the text, the number as a text. So um, x plus equals 2. So what do you think would the value be? So what do you think would the value be? Any answers from the students? Any answers? 9? Geo with the answer 9. Let's try out if it actually is the number 9. Let's try this out. So Geo has the correct answer. So in this operation, what happens is uh, x plus equals 2 is similar in function to x equals x plus 2. Okay. Wait a bit. Some students are having problems regarding our connection. Let me check. So, uh, this is as simple as it is. X plus equals 2 means that the value of x is currently being added with the value of 2. So, in this instance, the answer or the value of x is 7. So, 7 plus 2 is equals to 9. That's how the answer came up. So, let's modify this to minus. So, the answer would be, let's check this out. The answer should be, let's retry this again because I added a value here. So the value is 5. Okay? The value is 5. So there are multiple other assignment operators, no? So this is what we call compound assignment operators when there is a symbol being attached to it. So it applies to all other arithmetic operations such as division, multiplication, as well as modulo. Mm. Now, we are moving on with the other types of assignment operators. We call this the increment and the decrement operators. Okay, let me just fix everything up. So we have the increment and decrement operators. Increment and decrement operators are again unary operators, meaning they can function alone. So to simply use an increment or decrement operator, so to use an increment or decrement operators, you simply add either plus or minus twice. So for example, the value of x here is 7, right? So let's add x plus plus here. So the value would be 8. The value should be 8. Why did the value didn't change? Display text string value of, wait. Let's try this again. So the value is 8. Now, let's do the reverse. So, sir, what's the difference between putting an increment after or before the program? What do you think happened? What is the difference between putting the increment and the decrement operator before or after the operand? You notice that when we are putting plus plus x, it actually displayed as 8. But when we put the increment operator here, it shows up as 7. What do you think happened? So Gio with another answer. Let's see what his answer is. Correct. That is well answered, Gio. So what happened is we call this uh, as pre-decrement increment, and this one is uh, post-increment operator. Meaning, uh, this increment operators functions differently or behaves differently depending on which comes first, or rather, so most of the time, we depending on the situation, I mean, uh, uh, pre-increment and post-increment are being used differently. Okay, so for this instance, uh, post-increment doesn't show up, especially when we are using it to display text. But most of the time, we are going to use post-increment as well as post-decrement, especially when we are going to loop things. I will be explaining more of that when we have reached what we call this, the control flow, which is our last lesson for this module. Now, we are moving on to the logical operators. Logical operators are being used in a similar way that we are going to invoke an operand, or rather a Boolean operation. Again, Boolean operation only has two results. It could either be true or false. For example, let's create a condition here. You are going to learn more about this kind of condition in our third lesson in module 2, controlling program flow. Let's say x and y is 7 and 3 respectively. So let's say if x mm, what would be a good, okay, let's add another integer. Let's name this double z 0. Maybe the value, let's put the value as 4, or rather 4. So we're going to use the logical operator in a way that uh, we are going to display if how do we do with this approach? Let's say z is uh, rather it is going to be used as Boolean. So maybe we will deal with this in a control flow because Booleans are mostly used in conditions rather than uh, mathematical equations. So let's move on from logical operators. Now, um, we will go with relational operators for this time. So let's go with relational operators. Relational and the one logical operators is being used on the control flow basis. The difference between what we used earlier, which is logical operators and relational operators, is that logical operators usually are being used when dealing with Boolean operators. For example, Boolean operations rather. For example, the answer could either be true or false. But this time, we are going to deal with numbers. But we're still going to have an answer as a true or false statement. For example, if z is greater than if z is greater than 3, or now we are going to use a logical operator. You notice these two bars here, it means or. Z is greater than 3 or y x or z is, say, y. Z is greater than or z is less than x. Okay, for clarity's sake. It should display, let's say it should display. Let me copy this. Let's put this here. Remove this one. It should display true, or else it will display false. Simple as that. So, so from this operation, if z is greater than y, which is 3, or z is less than x, what do you think the answer will be? Again, I will explain this in English language. If z variable z is greater than y, or z is less than x, this one should display true. Then this one should display false. So what do you think the answer will be? Will it be true or false? Bea answered true. So let's check this out if it actually is true. It is true. So you are correct on that regard. Now, we are going to change this into an AND operator. So, where's the AND in here? The ampersand is located as a function of 7. So, let me show you what the logical operators have because we are already using logical operators at this instance. So, the logical operators are this one. Um, this one is called the AND operator. This one is what we call OR operator. This one uh, is what we call the. I'm sure this is quite familiar to you because after all, you already made truth tables a year before. So this is what we call the logical operators. Now we are already using uh, what we call relational operators. So there is greater than, there's less than. So before we move on, I think this is the last part of our lesson for today. Before we are going to create our practical uh, activity for today. So this is our last what do you call this? Exhibit in how to use this operator. So what do you think the answer will be if variable z is greater than y and z is less than x? Is it still true or false? And the answer is correct. Because z is in the middle between 7 and 3. Now, let's modify z a bit. Let's make this 2. And now we are going to put here, let's say this is or. Will it still be 2? Will it still be true in this instance? If z is 2 in this instance, what do you think the answer will be? False? The answer is still true. To remind you guys, if we are going to use OR operator, it means it only needs to satisfy one of the conditions. Again, if going back to our truth tables from 1 year before, if we are going to use OR operators, we have two conditions here, right? If we are going to use um, OR operator, it only needs to uh, satisfy one of the two conditions. The answer would be false if we used and here. After all, it doesn't satisfy the condition anymore. But we used or for this instance. That's why the answer is still true. Any questions before I exhibit the use of not? No questions regarding uh the use of the or and operators? Okay, no questions. Now we are going to use not. Not is usually used to reverse the value of a condition. For example, in this situation, it answered true, right? Because it satisfied this condition. What if we reversed z and y? So this is the one that caused the the true. It triggered the true because of z is greater than y. So let's see if we can reverse this, the answer into false by adding a not operator here. So as you can see, we are using not operator to reverse whatever is the value. If we are going to put, if the answer is true and we put not, it means it is not true, which means basically a false. So not tries to reverse any kind of value. Whether it is true or false, it will reverse it if we are going to use the not operator. Any clarifications or any questions from the students in our class today? Before we move on with our activity for today? Yes, Duke, what's your question?
Ano sir, guide deadline nato mga UI sir.
The deadline for the UI has was already last week, but you can still submit it.
Okay sir.
Okay. So, any questions with our lesson before we move on with our activity? Today, we will be using as many operators as we can for our activity to display our age in either hours, days, and minutes. Just approximate, of course. So, no questions regarding our lesson. Now, we will be moving on with our lesson for today or our activity for today. So, today, we will be recreating rather one of the problems that was presented by the CCIS department of the school, which is the college department. So there was one problem there in which how are we going to compute the age of people in terms of uh, how are we going to compute the days old of each person if we know just by years, if we know their age by years, right? So let's simply recreate that problem. So let's remove this unnecessary information. Let's uh, age in years, double age in years. So we are going to rename this double age in years. So let's remove these conditions. Oops, I removed. Um, let's say birth month, double birth month. What is your birth month? In number, of course, double, or rather, to make this a bit more realistic, let's use int because um, there is no age computed as 18.9, right? So let's make this a bit more realistic. Let's use integer instead of double. I'm going to teach you how to convert this to double instead. And birthday. Today we are going to output how many days we are actually living with, right? So another one is current year is what is the current year? 2021. And current month is 1. And current day is 26. So I would like you to input your age in years here, uh, your birth month, or rather, instead of age in years, maybe put it, mm, let's say birth year instead to make this more consistent. Let's say the birth year is 1991, 8, then 15. So the calculation is quite simple, right? But it ends up having what we call remainders. That's what modulo is for. So we will be using modulo in order to compute uh, the differences. So let's say we're in age in years, age in months, and age in days. Now we have age in years, age in months, and age in days. Now, age in years is quite simple, right? The computation is current year minus birth year. Then, age in months is current month minus. You run into a problem, right? You'll easily run into a problem. Did you notice what would happen if we are going to minus 1 if your age or your current birth month is 8? So I'm going to teach you how to deal with this. So let's say days is current day is minus birthday. So you'll easily run into problems with this. Because as you notice, the current month is 1. The current month is 1. And and what do you think? The current month is 1, but your birthday might be or birth month might be a bit bigger than this. So to circumvent this problem, let's put this condition. So this is our first dive in condition. So I would like you to copy this condition. If age in months is so age in month or rather current month, birth month is greater than the current month. Maybe let's put this condition here. Before we do any computations, let's make this add this here. So if birth month is greater than the current month, then birth month plus equals 12. Okay, we are using the assignment operator for addition. Then we are going to deduct this to the what do you call this? Current year. So current year 1. Is it clear to you guys? This is just the condition. Easy as that. Then we are going to do the same today for the days I mean. So what if the day, let's say your birthday is 15 or rather your day is 30 but the current day today is 26, right? So let's say birthday. Okay. Birthday. Now it should deduct birth month is equal birthday. Let's add 30 here. Then deduct current month by 1. If you never understood what the conditions here, you may ask the question, okay? So uh this is it. Let's try outputting this. So let's say my precise age is, let's remove this string value of first. My precise age is concatenator, then um, age in, okay, string that value of age in years. Then let's add another plus. Then a string literal years. Then string value of again. Now we are going to do this in months. Months. Then string that value of age in days. So let's try displaying this. My precise age is, then let's add maybe a line breaker instead. Okay, let's test this out. So why did it end up with negative? 19 months? Do you mean 19 months? So 8, current birth month. Did I deduct everything? Current month, 29 years. Let me just check the operations here. Age in months. So current month should be birth month. I did 12 years. Where is birth month? What do you think the wrong formula is in, or what do you think is currently wrong in this formula for it to show up negative 19? Wait, let me check. I should have deducted only 8. Hmm. Let's see. Age in months, current month minus birth month. Age in month. Birth month. Oh, I see. Okay. I I found the wrong answer. So it should be current month, not current. Okay. Okay. So that's the answer. So I want you to redo this equation, or rather this formula, for our operators for today. Any questions before we conclude our class for today?